when we get to doing like a Canvas tour and I show you guys all around the Canvas page, I do record a class every day so that you guys can see that at some point, like if you're absent or if you want to go back and watch again. So as you are first period, it will often be this class, but it may be later if I forget to hit the button. But I do record it. It doesn't do like pictures of you guys. It is literally just me recording my voice and what's on the screen. So if you guys hear me talking about recording, that's what it is. Literally just my voice and the iPad and the screen. Just because it will happen in this class frequently because you're my first class of the day and I'm going to try to remember to do it. Oh my gosh. So this is kind of where we ended yesterday. We talked with our probabilities and we worked with a coin flip and we worked with that kind of spinner a little bit. We're starting to look at what we remembered from probability from the last time we did it, which was probably 6th or 7th grade. Like, it's been a minute. So we got to the point where we wrote down the probability of some event as a fraction. And that's going to be kind of how we start this. So our probability notation, we're going to figure out, and my pen's going to be way too chunky for this now. So we're going to have, what this means is this is what is the chance event A happens. A happens. And we usually write this as our fraction. This is what we wrote yesterday, so if you have it down, like just above it, you don't need to write this again. I'm just going to put it up here so that it shows up on my documentation and stuff. Where we have our favorable outcomes over our equally likely outcomes. And we, for the most part, start out with these as a fraction. We can put them into decimals. We can put them into percents because we are super awesome calculator machines. We can do it. And we can simplify fractions. We can do that kind of stuff. But we're going to mostly start with fractions. These next three symbols look like brand new buttons on your keyboard. Because you go, what the heck? One of them looks vaguely familiar. The middle one is a U. It is, in fact, a U. The first one up here, this one's kind of an upside down U. And then there's a squiggle. These have very specific meanings and are mostly used in probability and a little bit in like pre-cal. We use them a little bit in pre-cal, but mostly in higher mathematics than that. So these aren't like, we're going to see these every chapter. But they are going to show up a fair amount in the next 2 weeks. Okay? So we're not changing the entirety of the math language, just beat a beat. And what these are different ways of saying and, or, and not. Just without having to write the words. Because in mathematics, when we have this kind of notation, what it does is it makes it so it is universal across all languages. So this would be the same if I was doing math in German, or if I was doing math in Arabic, or if I was doing math in Chinese. They use these same symbols. Because the point of these mathematical languages is to make it so that it's not the words that are the barrier in mathematics, it's the math part. So that's why there are slightly different symbols for words we know, but it's to make it more universal. So these all mean things that we know. So this one right here looks like an upside down U. The way I think about it is it's kind of a little baby A. And what this stands for is and. So it's the word and. So this is now talking about the relationship between two things happening. I flip a coin, I roll a dice. Two things. Or I roll two dice. Or I flip two coins. Two things. But I need event A to happen and event B to happen. Both have to happen. So this is also called the intersection. My screen's being a jerk. Let me move. There we go. So this is also called the intersection. And this means both events happen. So if we look at these pictures up here, I know they're not in your notes packet, but these little circles down at the bottom. I'm going to turn this so I can actually label stuff. What this is saying is that this would be event A in this left-hand circle. This is event B in the right-hand circle. And since both happen, it's this part right in the middle where they cross. Both are happening. It has to be both. The coin lands on heads and I roll a 6. Both happened. So and means both. The next one we have, I'm going to do it as purple. So this one is the U. So it's the upside down version of that. And what it's called the union. Pen, come on, thank you. It's the union. And what it means is either. It could be A, it could be B, it could be both. What is going on with the delay on this pen? I'm having to go very slow. So it's either. So it could be A, it could be B, it could be both. Totally fine. So that's what this middle picture is. This is our or. It could be A, or it could be B, or both. So this guy. So it could be A, it could be B, it could be both. So again, if I think about my die and my coin, I could land on heads, or it could be a 6. Could be both, but if I just land on heads, that counts. So what is our union? It means either. We usually say or. And then the last one up here is the little squiggle. And all this means is not. Is technically called a tilde. It is a button on the keyboard on your computer. It's up with the next to the 1 on the number row. It's the one next to the 1. It's called a tilde, and it just means not. So it's like a negative. They just don't want to put the minus in with letters because mathematicians like to make things complicated. So it's like a negative just with words. We do have 2 little formulas that I'm going to give you here. This information will always come from the data for our probability. Our intersections are going to come from the data as well. The union or has a formula to it that's going to look really complicated. I promise I'll walk you through when we get to it. Okay, but I'm going to give you the formula so we have it. So to get the probability of a union, I'm going to do it in the same color just so we can tell. It's the probability of A. Gosh, pen, can you stop? Plus the probability of B minus the probability of the intersection A and B. Sorry, my youngest just texted me they couldn't get on the Here Comes the Bus app. So all this means is this is looking at this piece here, the circle down here, and it's saying if I take the probability of one event happening, like our A over here, and our probability of B, we got to watch out for the overlap. And I will go more into detail with that when we have a big table to look at and we have numbers, because right now it looks weird and I just told you a whole bunch of Greek. All right, so one other little baby formula that we will be using today for sure is the not. And so I'm going to put it as an equal sign too. So we're going to have our probability of not A equals 1 minus the probability. That's a weird P. Love that. My stylus is losing its mind. Probability of A. Grumpy today. So there's a whole lot we just wrote here, and a whole lot of craziness. And it feels like we just wrote a little bit in foreign language. I promise we will work through all of these things. But it's just easier if they're all in one space, even though you don't understand what we just wrote down. Okay? Questions, surface level questions on what we just did here. Because again, I promise we're going to work through them all. Okay. So, we're going to start out here to remember, again, we talked about these a little bit yesterday. But again, before that, it's been 2 months since we mathed. I get it. So we're going to think about 10 over 15 and how we would reduce it as a fraction, put it as a decimal, and what it would be as a percentage. So if we have 10 over 15, how can I reduce that as a fraction without typing it into a calculator? Ooh, that is sticky. Say it louder. Somebody had an idea. I'm not saying it was wrong, I'm just slightly deaf. I can divide both of those by 5. Absolutely right. I have to grab it. This is sticky and it's going to drive me nuts. There we go. So 10 is divisible by 5, and 15 is divisible by 5. And I'm not changing it because it's 5 over 5, which is 1. So those are going to mean the same thing. As long as I can take the same thing out of both of them, that's totally fine. So what does that give us when we simplify it? 2/3. 2 over 3. So we may not know 10/15 off the top of our heads, but do we know what 2/3 is as a decimal? That is the same thing as 0.66666, and we put a little line over it. That means it keeps going. Repeating. It's a repeating decimal. What is it going to be as a percent? 66%. To switch from decimal to percent, we move 2 spaces. So this will become 66.66%. And it still is technically repeating. We just don't usually go that far. I try and make sure whenever we have something that we're turning in, quiz, homework, whatever, it'll tell you where to round if we need to. I try. Two more feeling like very random questions, and then we'll get into working with these things, okay? So it says in your book it's arranged incredibly differently than this. Oh, and look, I have extra questions up here, and we're not going to do those bottom 3 because we don't need to, because we just already wrote these. So in your little notes packet, it says key idea. Express the probability of an event that is certain to occur. Certainly occurring. What is the probability that the sun will rise today? 100%. Going to guarantee to happen. So 100%. It's like barring, cataclysmic apocalyptic events. We're assuming no apocalypse. Guaranteed to happen. What is the probability? I will arrive every morning with coffee. 100%. What is that as a decimal? It's 1. Just like we did for the others, move our decimal place here 2 to the left. Percent to decimal, we go left. Decimal to percent, you go right. So the decimal version of 100% is just 1. So if we put something as a fraction, let's just say we're going to pretend like looking at the coin. So if we have 2 total options and it's guaranteed event, I flip the coin. What's the likelihood I get an answer? 100%. So what would I put that as my numerator for our low fraction? 2. So they're going to match every time. So anything that is guaranteed to happen, my numerator and my denominator will be the same. So here is our percent, decimal, fraction. What about something that will never happen? So impossible event. What is the likelihood I will never misspell a word again in class? Something that will never happen. What's the probability? 0. Guaranteed. Guaranteed. At some point you will find something. I was like, in first period, y'all will get it the worst. Just saying. So impossible events have a probability of 0. The likelihood we win the lottery without buying a ticket. 0. The likelihood everyone arrives with energy and hyped up in math class at 7:15 in the morning. Woohoo! Yeah, 0. I'm practical too. What is that as a decimal? 0. And if we think about like the coin thing again, what would my numerator be if this was in a fraction? 0. So the chance that I flip a coin and it lands on the side. Yeah, that doesn't happen with real coins. Those are trick coins when it does that. You can balance them really carefully sometimes, but never on a flip. Okay, so certain events are guaranteed. That means this will happen. 100%, 1. Impossible things are 0. So all of our answers for this chapter are going to be between these two things. Everything we're doing is going to be between 1 and 0. So this chapter is going to have a lot of decimals and a lot of percents. If you were winding up with answers of 110%, 150%, something's going wrong because you can't actually do that. You can't give 110%. It's nothing. Mathematically, that just means it's your new 100. Okay? So now we're going to look at the next page and we're going to practice with them, some of these, and we're going to get to experience using them. So it says a fair die is rolled. That is an overcomplicated way of saying a regular die. Nothing fancy, nothing crazy. One of these guys. I love my big mama. She's a chonker too. One of these regular things like you find in a Monopoly game or a Gen Con. I love her. I'm playing on Sunday. I'm so excited. So regular die counts numbers 1 through 6. We are only going to be working with fair die in here. So even if it doesn't say it means one of these guys. I'm not tossing trick dice at you. That's an AP stats thing, and those are really fun, but also a lot more complicated. So we're looking at one of these guys. We're going to start by just looking at part A, because they put a lot of things in here. So it says, let A be the event of rolling an odd number. And question A says, calculate the number of possibilities for that. 3. There are 3 odd numbers. 1, 3, and 5. Odd numbers. So then what is the probability that we roll an odd number? 3 out of 6. 3 out of 6. Does that simplify? Yes. To what? 1/2. So that's the same thing as 1/2, which is the same thing as what? 0.5. So then last one is as a percent. 50%. Boop. Especially through the beginning parts of this chapter, we are going to do all 3 just to practice it. You won't always have to, but we are for sure going to start about it. So then the next one, part B, says let B be the event of rolling a number bigger than 3. How many numbers bigger than 3 are there? 3. It's different ones though. This one, and this one. So we still have 3 options. So what's the probability of event B happening? Just looking at green. We're ignoring purple for right now. Say it louder. I heard it was 6. 3 out of 6. Because we're just looking at B. The probability that we get a number bigger than 3. So once again, we have 3 out of our 6 options. Which again will simplify. So this has also got a probability of 1/2. Which is also a probability of 0.5 and percents of 50%. Our last one really is where it starts to get a little bit weird. So we want to identify the probability, that's what the P stands for, the probability of A and, what did you say? All right, so the probability of A and B, and both. So when it's upside down like this, it kind of looks like a little A right here. If I cross it, look, that's an A, woohoo. So that means this is and. It has to be both. So I need it to be both an odd number and bigger than 3. How many odd numbers bigger than 3 do we have? 1. So what is my probability? 1 out of 6. The only one that has both is 5. Does 1/6 simplify? Nope. What is 1/6 as a decimal? Do you know off the top of our head? Totally fine if we don't. I'm going to use this opportunity to point one thing out. Do you ever feel like you need one? Calculators are over here. Welcome to have them. I have 3 more bins. I just only have 1 bin out right now. If you ever need a pencil or a pen or eraser or ruler, that kind of stuff is also over here. Also, don't use the wall one. It makes a giant mess, and it's from like 1972. I literally think that pencil sharpener was in this room when I was a student here. It's trash. Don't use it. So 1/6 is not one of those ones that we need to know off the top of our head frequently. Like, we are never going to have a time in here when I say, don't use your calculators, figure it out. We got calculators. We live with calculators. Y'all have one here. We got calculators. Would destroy my math teacher's minds to have me say that to them. So what we could do is we have 0.1666, blah, 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 blah. Back in the day, they made us do math, like speed things. So like, you'll never carry a calculator with you everywhere. Look at me now. Sure do. It even has, I don't know if you know this, Scientific. Has all the extra buttons. When you turn your iPhone sideways, it gives you all the extra buttons, okay? So your calculator, you can use this, just not on tests. So there will be times in here when I recommend highly you use the yellow ones, simply because you can't use your phone calculator on the test, and there are some slight differences in how you have to do things. But I'll walk you guys through that as we get to problems like that, okay? So what would this be as a percent? 16.6%. Okay. Now that we've worked with those again at least once, how are we feeling about that? Any questions as of right now? Okie dokie. Because the next one is very similar. We're just going to practice, instead of using a die that you are familiar with, we've got billiard balls pooled. So, because this is technically from the textbook that we're not using. So we've got that billiard balls are numbered from 1 to 15, and they are either striped or solid. So we are picking a random ball, and we want to know the probability of its event. We want to know the probability that the ball is striped and even. So I want you guys to try and see if we can figure out, first, what's the probability it's striped? What is the probability that it's even? So the solid ones are these ones up here. The striped ones are these ones down here. So think about it for a second. See if you can figure out what is the probability that it is striped. Striped always looks wrong. Just looking at striped first. What is the probability that we would pick a striped ball? 7 out of 15. Say it again. No, it's okay. Sometimes it's just that I physically can't hear. Okay. I was like, and sometimes I understand that all it takes is to say the question out loud and our brain processes it. 100% valid as well. So, there are 1, 2, 3, 4, 5, 6, 7 balls that are striped. So we have 7 favorable outcomes out of 15 possible outcomes. 15 possible balls. Because what they're saying is, I put all those balls in a box and say, pull it out. It's probability that sucker's got a stripe on it. You can't look. That way. So then similarly, what is the probability we would pick an even? Try that one. See if you can figure out what is the probability we would pick an even number. Just even. So now we don't care if it's striped or solid.
Would it also be 7?
Yeah, 7 out of 15. It is also 7/15. I love that they keep doing that to us, where they give us the same exact odds for both of them. And so much fun. Because there's 7 even ones. But that's not what the question up here is. I want to know the probability, so now we'll get to use these multiple choice things over here. The probability that it is both. So I'm going to use my and notation. I'm just going to call it S and E. I just don't feel like writing striped and even that many times. So I use the same colors, but I'm just calling it S and E. So what is the probability we pull a striped even number? 3 out of 15. Because looking at our striped balls, there's 1, 2, 3 of them that have even numbers. So our probability is 3 out of 15. However, I don't see that in my list of available options here on the multiple choice. Uh-oh. Simplify it. Oh, snap. So what can both of those be divided by? 3. So if I divide this by 3, and if I divide this by 3, which we can absolutely do because 3 over 3 is the same thing as 1. I can change anything by a 1. It's a weird one, but it's a 1. So that gives me 1 over 5. So of our multiple choice options, what would our answer be up here? I know it's small. A. Boop. And I know you guys don't have the multiple choice in your book, but like, still a good idea to look at this, practice this kind of stuff. And okay, so on the next page, we are gonna skip most of the top of it because honestly, I don't like that one. But I don't like that one, and I don't like that one. Okay, so this is on page 3. It's the little bottom one. It's this very bottom one down here. This is what we're doing, and it's the topsy-tops up here. Except I don't like that it has that much written here. So I'm going to come back here. And sorry, you guys are my guinea pigs because I hadn't actually worked through this one yet. So we're going to do that bottom one from page 3. I just had way too much written up there for us. So they are telling us that the probability of rolling a die and getting a 3. So now we're looking at one of these guys again. We're back onto a die that comes in a game. Is 1 out of 6. Because that's one side out of 6 options. What we're asked here is to find the probability of not getting a 3. So we're going to find the probability of not 3, 5/6. How did you figure that out? You're absolutely right, but how? How do we know that? Yeah. There's only 5 left. You're exactly right. You're also exactly right. There's many ways to do it. Sometimes I will ask you guys obnoxious questions like that just because I want to see how we got there. And it's absolutely fine to say blind guess. That lets me know. That's all I'm asking you to do is because I can't read your mind. My psychic powers haven't come in yet. I always hope for it. But it's like showing work just out loud. Okay? Just lets me see what's in your brain. Once my psychic powers come in, you never have to answer a question again. But they're not here yet. So, there are several ways to find this out. So you can think through, well, if I got a 1, a 2, a 4, a 5, or a 6, it would not be 3, and that's 5 options. But if you think about, I don't know if any of you guys are gigantic nerds like me, playing like D&D, and all the dice that have all kinds of different sides, like 12-sided, or 20-sided, 30-sided, like this thing's full, all dice. So sometimes we might not know for sure how many there are that don't meet it. So another way to do this is to use that formula we started out writing down, where I'm going to take the probability of the not being 1 minus the probability it is. So I can find the probability of not 3 by taking a certainty, 1, that I roll a dice and I'm saying, all right, I know that one doesn't work. So we're going to take it away. Because they told us the probability of 3. So we're doing really 1 minus 1/6, which gets us exactly to our 5/6. Sometimes you can use a formula. Sometimes you can logic your way through it with your brain. And both are right. For some people, this will make way more sense. And for some people, brute forcing it with your brain will make way more sense. There are many pathways through these things. We are getting into enough mathematics and high enough mathematics now that you guys are going to have more than one path through problems. And that's okay. You might not match the person next to you exactly when you do stuff. You should probably get the same answer, but your pathways may be very, very different. Okay? So we have about 5 minutes left at the end of the period. The announcer bell stopped being on us. So I'm going to pass out the first homework. It is going to be due on Tuesday. So I'm giving you 2 school days. You guys could do everything on it. It's number 11 we haven't quite gotten to yet, but you guys probably should figure it out. It should be hopefully a little familiar. I believe it's review.
But it's a review for like 7th grade, like champion.
This. All right.
Is it reward?
Oh. Okay. It's all good. It's okay. No, 100%. I was gonna say, if you say most any name loudly, I will answer to it. Like, no shade, no shame. All right. All right. There we go.